All right. This is software development, GPT style. So who am I? My name is Ashley. I'm a second-year security major. I am the current president of We Assisted RIT. I am also the Weirdo S lead for ISTS. I'm on the RIT Sec Red team. I'm an incoming software engineering intern at Apple. And I've worked at MITRE in the past, done some FFRDC stuff, and I really like writing software, playing table tennis. So what is ChatGPT? Many of you may be asking. I know you've heard about it a ton. Everyone's talking about it. Well, it's a natural language processing model created by OpenAI that generates human-like responses, yada, yada, yada. That's really, really complicated, right? I don't want to have to read all that. So let's try that again. I'm now going to have it explain it to me like I'm 5. OK, ChatGPT is like a smart robot friend who can talk to you on a computer. You can ask it questions. It will try to give you a good answer, just like a real friend would. ChatGPT knows a lot about many things, but it's not perfect. And sometimes it might not have the right answer, but it's still fun to talk to and learn from. And I think that perfectly describes how it should be used. This is much clearer. And it also demonstrates one of the coolest features of ChatGPT, which is the fact that it learns and knows previous responses and prompts in the conversation you're having with it. So when you open up OpenAI ChatGPT, you notice you have that conversation session. Everything you type in that session, it's going to remember, and it can influence future prompts, which is a really, really cool feature we're going to utilize. So you may be asking yourself, isn't this a Swen talk? Well, yes it is. ChatGPT can be pretty easily integrated into the software development process, and I'm going to show you how. So there's this really cool thing called pair programming, and it's basically a software development technique in which case you and your partner are doing one of two things, driving or observing. The driver is typically writing the code, focusing on basically just getting the job done. And the observer is there to look at it, help you refactor, help fix bugs, basically look at the entire design of the system and how your piece of code fits in. And yeah, there's this funny little meme. I'm sure some of you have experienced that where you're working on something alone and then suddenly a bunch of people crowd around you and you have no idea what to type now. That can definitely happen. But what won't happen is if you're doing it with an AI. So let's start with GPT observing. So I gave it this prompt, and it was a conversation I had with it. And I said, for the rest of our conversation, refactor all presented code using clean code fundamentals, as well as comment the code in a specific Sphinx style of documentation. And it was very, very happy to do that. So we then had some starter code. You may or may not recognize this from my previous talk about building Bifrost. This is an agent, and it's a very, very large bloated function, so it's going to be really great to work on. And it's basically about registering an agent with a server. You see it does a couple things. It does some system enumeration, grabs some system, local IP, user info, all that kind of fun stuff, marshals some JSON, sends a post request to the server, and then it basically retrieves back a response, gets its agent ID, and then returns. So let's see what ChatGPT does to it. So first off, you can see that there's error handling. That's pretty cool. We shouldn't handle our errors. We shouldn't let them go unanswered. So that's the first thing that's pretty neat. The other thing, too, is that it has changed the variable naming. So one thing you may or may not know is that Go is camel case in terms of the style guide. And so it's just automatically done that. It's refactored all the variable names into camel case, which I think is pretty cool. And it makes sure that your Go code is following proper guidelines. So that's kind of the basics. Also, the documentation. I feel like this is something that a lot of you probably will use in your classes. So this is actually really, really good docs. It intuited exactly what the function was going to do. Register the host with the server, gathers system information, such as the host information, IP, username, and sends it back to the server as a JSON payload. Wow, that sounds awful like when I was giving a description of it. How crazy is that? But yeah, this is a really, really cool feature. It can be used in much larger applications. So say you're writing a whole bunch of code, you just paste it into GPT, have it auto-dock it, and then you don't have to worry about writing the docs anymore, which is pretty cool. So the other thing that's really cool is you can do additional refactoring as well. So this is just one example of a prompt you can give it, but I told it, hey, can you split this like really large bloated function into several smaller ones that fall under similar layers of abstraction? And it did just that. So if you look back to the register function, you can see that it now has a couple of different functions: gather system info, prepare post body, make post request, and process response. All of those things are helping it register with the server. And if you watch my clean code talk, you would know that now everything is at similar layers of abstraction. You have this big thing, which is registering, and you split it up into smaller tasks. And it actually did it really, really well. I tested the code after, and it just like worked straight out of the box. For brevity's sake, I didn't include all of the smaller functions, but you can see gather system info right here. And it does just that, which I think is really cool. So how about driving? How does GPT do about driving? I'm not talking about it on the road. We've seen what Tesla does. How can it write code? So I gave it a simple prompt. It was write a simple script to make requests to an API that then prints out a dad joke. Simple enough, right? And it gave us this response. And it's doing three things. It's making a GET request to the API. In this case, it is icanhasdadjoke.com. It then is reading the response body, and that's printing it out. Some of you may already notice an issue with this, but we'll see that in a sec. So does it work? Well, I went directly and I ran the code, and you can see that it just gave me a blob of HTML. It's doing no processing of the return response. It's not asking for JSON, and it's very, very simple. It's very stupid. So let's give it some help, right? We already learned earlier that we can, talk to GPT. It remembers previous prompts. So let's refine that. So I told it, the code is currently only printing out the raw HTML on the page. I want the actual dad joke only. And so it gave me this one. This script is a little bit better. You can see that it is looking at the response status, and that's basically all now. And it's doing like a weird typecast into a string, which does the same exact thing that it did earlier when you do from .println. It also doesn't work. So we're going to give it a better prompt. It's still just printing out the HTML of the entire page. This is a little more specific, believe it or not. And it actually knows exactly what I want it to do now. So you can see it makes a request object, and now it's actually setting the header so it receives application JSON. So it's looking for a JSON response. It also made a joke struct, which has both an ID and a joke. It actually looked at the API docs and saw that that was like the response it was getting back, which is pretty cool. And then it should be printing it correctly after decoding the JSON and storing it into the joke struct that it made. And if I run the code, we can see that it works. So that's pretty cool. Success. So what did we learn? Our communication skills suck. If we look back to the previous prompts, I say the code is currently only printing out the raw HTML on the page. I want the actual dad joke only. Or write a simple script to make requests to an API that then prints out a dad joke later. None of these are very specific, right? And so you can kind of see this trend where longer, descriptive, specific prompts help ChatGPT give us exactly what we want. And so I kind of made this funny little thing, one prompt to rule them all. And it basically turned out the exact same code just on the first exact prompt. But I said, write a Go program that fetches a dad joke from said API and prints it to console. Read the API docs before writing the script, which I think is something you guys probably should practice if you're trying to interact with APIs. Maybe read the docs first. And it just runs, which is pretty cool. So what did we learn? ChatGPT, while extremely powerful, is not always right, but with guidance from a smart pilot, it can be used efficiently and effectively to speed up the development process. Gone are the days of having to write your own documentation. You can refactor it by just putting it into GPT. You can split it into smaller functions. You can do way crazier things than that that are outside the scope of this presentation. But yeah. So what are some future applications? Where do I see this technology kind of going? I think something really cool would be like AutoDoc and CI/CD pipelines. So you submit your undocumented code, And there is a script, probably like a simple little Python tool, that reaches out to the matured GPT or natural language processing API, and you ask it to document your code. And it'll just do that. Other cool things you can do with this is bug fixing. So if you feed it a broken script and you're like, hey, find the bug for me, it can do that pretty often. I've done like a lot of testing with that, and it's something that it's pretty decent at. Refactoring code, it's excellent at. Occasionally there will be like a couple of mistakes, like it'll rename a variable or just put a variable that like doesn't exist. But 99% of the time it's really good. And again, if you're using this for pair programming, you should already have like some amount of knowledge of like how to code, so you should be able to like point out those mistakes. And it's doing the majority of the work for you, which is pretty cool. The other thing is augmenting search engines. So as the like model matures, using it as a complete Stack Overflow replacement, I think is really cool. You don't have to rely on the Google search engine and highly upvoted responses to be able to get clear answers, because if any of you have read through a Stack Overflow thread, you know it can be kind of painful sometimes. And yeah, so here's my contacts, my LinkedIn, my GitHub, my Twitter. You should totally follow those if you found this talk interesting. And yeah, your sources. And yeah, any questions? All right, thank you.